We live in a universe of predictable, nested cycles. Every year, the Earth completes a stable orbit around the Sun, a mechanical rhythm that defines our calendar and our sense of stability in the solar system. Scaling up, our solar system is locked into a circular journey around the Milky Way. This chart illustrates that nested motion. However, that circular pattern breaks. The entire Milky Way is moving violently off course, sliding in a straight line. We are traveling at over 1 million miles per hour toward a destination that has nothing to do with our orbital path. Despite our feeling of standing perfectly still, we are passengers on a galactic vessel accelerating through the dark at an imperceptible speed. This movement is the result of a specific, invisible coordinate in the universe, exerting a constant pull on our local group of galaxies. It appears a giant cosmic ghost has hooked the Milky Way on an invisible tether, and it is slowly reeling our galaxy in. For decades, astronomers pointed telescopes at those exact coordinates and saw nothing but empty, dark space. Astronomers named this massive, invisible pulling force the Great Attractor. The Milky Way's velocity confirms immense gravitational power exists at that coordinate. Yet for years, we could find no physical object to account for the pull. Why would a force capable of moving entire galaxies be impossible to see? The source of the pull remains obscured by the very structure of our own galaxy. This blind spot is known in astronomy as the Zone of Avoidance. To look toward the Great Attractor, we must look through the thickest, most crowded part of the Milky Way. This region is a dense wall of our own stars, cosmic gas, and swirling space dust. It is like trying to spot a distant mountain while standing in a dense, foggy forest. The nearby moisture and trees block any view of what lies on the horizon. Traditional visible light telescopes cannot penetrate this barrier. The light from our destination hits the dust and scatter, leaving us blind to the source of the gravity. To see past the fog, scientists turn to X-ray and radio telescopes. This chart shows the mechanical difference in the wavelengths. While short, visible light waves bounce off dust particles, the elongated waves of X-rays and radio signals slip through the empty gaps between them. Using these penetrating frequencies, researchers began a systematic scan of the dark patch of space behind our galaxy's core. The X-ray data eventually cut through the cosmic dust, mapping the structures that occupy the space on the other side. These technologies bypassed the physical barrier of the Milky Way, allowing us to identify the massive structures hiding in the Zone of Avoidance. Initial theories suggested a supermassive black hole might be the source of the pull, waiting to consume our galaxy. The data revealed a different reality. The Great Attractor is not a single point of matter, but a massive region called the Laniakea Supercluster. This visualization scales outward from our galaxy to show the true scope. Laniakea is an interconnected neighborhood containing tens of thousands of individual galaxies. Each of these galaxies possesses immense mass. When clustered together, their collective weight creates a gravitational force that reaches across millions of light years. The Great Attractor is a demonstration of how gravity operates on a massive scale, pulling entire groups of galaxies toward a common center of mass. Our trajectory leads toward a densely populated region of the universe. Our million-mile-an-hour journey is moving us toward a bustling cosmic city, a hub where thousands of galaxies are converging. The physics involved are as predictable as an object falling toward the Earth, simply scaled up to the level of galactic clusters. The source of the pull is now in view, even as the Milky Way continues its million-mile-an-hour journey through the dark.